3D graphing is really hard. I wish someone knew how to help me. A 3D graph is a graph with 3 variables instead of 2. All 3 variables must be real numbers and can be graphed on a 3-dimensional coordinate system.
So a 3D graph has 3 axes instead of 2. It has the x, y, and z axes. So highlighted in blue are where the negative values are. So on the z-axis they're below, on the y-axis they're to the left, on the x-axis they're in the perspective view towards the back. So it may seem simple so far, but then it gets more complicated when you see a problem like this, where it's x squared plus y squared plus z squared equals 9, which the final shape should be a sphere. But in order to start drawing that, we need to know the basics of 3D graphing and how to do the basic equations and point.
So in order to find what point this is, you need to know the x, y, and z. And so you can look and the x goes 1, 2, 3. So you know that x is going to be 3. And y, it is going 4 in this direction. But you need to keep in mind that that's negative. So it's not 4, it would be negative 4. And for z, it's going up 2, so z is 2, so that point is 3, negative 4, 2. To graph the point 2, negative 1, 3, on the x-axis you'll have to go up 2. It looks like down, but it is in fact up. So you'll go like there. And then negative 1 on the y, like this. And then up 3 is about like that. So the point 2, negative 1, 3 is about right here.
So now that we've gone through how to graph a point, we're now going to go through how to graph an equation. So if we start with the equation negative 10x plus 5y minus 10z equals 20, we can use this to create a 3D graph. So we start by finding the x-intercept, which is by plugging in 0 for the y and z coordinates, you find that the x-intercept is negative 2. So then using this exact same process, you can find the y-intercept by plugging in 0 for x and z, which gives you 4 for y. And then, to find the z-intercept, you do the exact same thing by plugging in 0 for x and y, giving you negative 2 for z. So now you can take this information and graph it. So with the points that you now have, where x is negative 2, using the purple line you go back 2, and then the y-intercept is positive 4, so on the green line you go over 4, and the z-intercept is negative 2, so you go down 2. You now have 3 points which you can connect in a triangle. Now this triangle is a small representation of an infinitely large plane in 3-dimensional space, which is what the equation has allowed us to find. So we can use the exact same process on another equation, 4x minus 3y plus 6z equals 24. So using the exact same steps as last time, we'll find the x-intercept, which is positive 6. We'll find the y-intercept, which is negative 8. And then we'll find the z-intercept, which is positive 4. And we're just using the same process as last time by substituting 0 into the variables that we don't want to find. So now using this information, we can plot the points on the graph. So for the x-intercept, which is once again the purple line, we're going over 6 in the positive direction. And then for the y-intercept, which is the green line, we're going left since it's negative 8. And then for the z-intercept, we're going up on the blue line, positive 4. So this once again gives us a triangle which represents a plane in space. Now that we've understood the basics of 3D graphing, we can approach the equation x squared plus y squared plus z squared equals 9, which we know is supposed to be a sphere. So given this equation, we can start off by looking at this, and since we're given 9, the 9 indicates that the radius of the sphere is 3. So we find where x, y, and z equal 3 in both positive and negative directions. So positive 3, negative 3, positive 3, negative 3, positive 3, and negative 3. And these are the points that we are going to use to create our sphere. So there are a couple of ways to think about this. You can connect all the points with a circle so that you have a circle in the x-axis, y-axis, and z-axis, or you can use arcs to connect, for example, negative 3 to positive 3 and up to positive 3, creating that arc and just doing that 6 times. But however you do it, you can use this equation to find the graph of a sphere. And while this is an okay drawing, it is much better represented on a computer where they can do the actual calculations.
In school, you learn about 3D graphing in Calculus 2 and 3, but can you use this in the real world? Yes. 3D graphing can be used to create 3D computer models and 3D data plots and anything in between. It is most commonly used in science and engineering fields. Finally, understand 3D graphing.